Good morning everyone. Welcome to the class for Target IBPS Prelims 2018. As we near the end of the course completion for the prelims examination, today we'll be discussing the topic on permutation and combination. Right, it's a topic from algebra. Permutation and combination was a constant feature of exams till almost 2014-15, but after that it has become less in terms of number of questions. But yet it has come in the past in the exams, and that is why it's very important to learn this topic also. Right. So we will be doing permutation and combination in two sessions. The first session today I will be doing for permutation, where we will understand the basics of factorials and the concept of permutation, followed by the next session on combination, where we will learn the formulas of combination. Right. The goal for the class is to understand the basics of permutation and combination, to understand concepts like factorials, fundamental principle of counting, different formulas of permutation, and then also discuss problems based on that. Okay. Now before we begin with the topic, first of all let's see the previous session contest question. So here we have the contest question from the topic of volume and surface area, that is under geometry, that's the topic of mensuration. So we have the question here: the radius and height of a right circular cone are 15 and 20 respectively. Let's say it's in centimeters because data is entirely in centimeters. What is the curved surface area of the cone? So this is a basic formula based question. So we should know that the cone, two main formulas are there for cone. One is the volume formula, it's 1 by 3 pi r square h, which requires radius and height. Then we have the curved surface area formula, curved surface area, the area of the curved part of the cone. So curved surface area formula is here also is given to you, pi r l. Okay, so that's pi into r into l, where l is the slant height of a cone. When you make a cone, a right circular cone has a circular cross section. We have the radius given to you, this is the radius, and this is the height of the cone. Correct? The angle here is 90 degrees, and this inclined height is what is called as the slant height. Now if you can see, this looks this is a right angle triangle. So using the formula of the Pythagoras theorem of right angle triangles, we can say that r square plus h square is equal to l square, or we can say l is equal to under root r square plus h square, and this is what we have done here. The radius is 15 and the height is 20, so under root 15 square 225 plus 20 square 400, 400 plus 225 625, under root is 25. So we get to know what is the slant height of the cone, and then we put everything in the formula here, pi r l. So pi is left as pi because all answer options contain pi. We don't need to put the value of pi as 22 by 7 or 3.14. The radius is 15, the radius is 15, right? So radius is 15 and the slant height is 25. When you multiply 15 into 25, the answer becomes 375. Correct? So that is how we get the answer for this particular question, 375 square centimeter. So this is a question from the topic of volume and surface area. Now let's start with the topic of the day, that is permutation. And in permutation, first of all we'll understand the concept of factorials. Factorials are important for permutation, combination, as well as the topic of probability, and sometimes questions on number series also come based on factorials that we have discussed earlier also. Now let's understand what is n factorial. This is how we write, this is the factorial symbol. So n factorial. Right? How do we represent factorial? By this exclamation mark. In books earlier, factorial was also represented like this. This is also n factorial. Now n factorial is the product of the first n natural numbers. Okay, so we write like this. This is how we write n factorial. N factorial is the product of the first n natural numbers. You know what are natural numbers? Positive integers starting from 1, then we have 2, 3, 4 up to infinity. So n factorial is equal to n into n minus 1 into n minus 2 and so on. We multiply till we reach reach 1. So that's what is your n factorial. Okay. So if we take an example of 5 factorial, 5 factorial is equal to 5 into 4 into 3 into 2 into 1, and that value is equal to 120. So how will you write 4 factorial then? If this is 5 factorial, 4 factorial is equal to 4 into 3 into 2 into 1. So we start from 4, we go on multiplying till we reach 1, and the value of 4 factorial is 24. Alright. Now if you see here, 5 factorial also contains 4 factorial. See, 4 into 3 into 2 into 1 is nothing but 4 factorial. That means we can write 5 factorial as 5 into 4 factorial. If you want, we can also write it as 5 into 4 into 3 factorial. We stop at 3, we put the factorial symbol at 3. That means we can write n factorial as n into n minus 1 factorial. Like 5 into 5 minus 1 is 4, right. So n into n minus 1 factorial, that is how we can write n factorial as. We can also write as n into n minus 1 into n minus 2 factorial. From this particular equation that I have written here, that n factorial is equal to n into n minus 1 factorial, we can also write that n minus 1 factorial is equal to n factorial divided by n. Clear? Now in this particular equation, if you put n equal to 1, what will happen? If you put n equal to 1, we get 1 minus 1, 0 factorial is equal to 1 factorial, which is 1, divided by 1, or that is equal to 1. So that is how we get to know that 0 factorial is equal to 1. This is just a proof for the thing that 0 factorial is equal to 1. Now then we have 1 factorial which is equal to 1. So we should know factorials till 7 minimum for the purpose of calculation in exams is very useful. If you know factorials till 7, so 2 factorial is 2, 3 factorial is 6, 4 factorial is 24, 5 factorial is 120, 6 factorial is 720, and 7 factorial is 5040. So these are your, you can go with 8, 9, 10, but you can at least remember till 7. 7 factorial is 5040. What we also need to know before we start with the formulas of permutation and combination, and why are we learning factorials, because we should know how to simplify factorials. Okay. So let us see, if I want to find out what is 10 factorial divided by 7 factorial, what is this value? 10 factorial by 7 factorial. So the way we simplify factorials is different from the way we simplify numbers. What we do is, first we write down 10 factorial as 10 into 9 into 8 into 7, and then we stop at 7. The way we stop, we put the factorial symbol there. Now this we are doing so that we can cancel the factorial in the numerator and denominator. Factorials can be cancelled only when the value is same. So we have 7 factorial divided by 7 factorial, we can cancel them, and what is left is 720, and incidentally 720 is equal to 6 factorial, right. So 10 factorial by 7 factorial becomes equal to 6 factorial. This concept we must understand. Also, to take factorials, how to take factorials common. Let us say for example, what is 5 factorial plus 6 factorial plus 7 factorial. How do we take factorials common? So we can say here, let 5 factorial be common, then in the bracket inside we can say 1, because 5 factorial into 1 is 5 factorial, right, plus 5 factorial into 6 is 6 factorial. So we get here 6, and here we get 6 into 7. So 42 plus 6, 48 plus 1, 49, that is 5 factorial into 49. Clear? That's how you simplify and take factorials common. So two things we have seen: how to cancel or simplify factorials in the numerator and denominator, and how to take factorials common in addition or subtraction type situation. Okay. So this is your basic understanding of the concept of factorials. Next we will go and understand what is the fundamental principle of counting. Permutation and combination both are essentially counting questions. We try to find out the number of ways in which something can be done. So almost all the questions on permutation combination will contain the phrase number of ways, find the number of ways of selecting something, let us say 2 students from a class of 10 students, or the number of ways in which the letters of a particular word can be arranged, or the number of ways in which 6 persons can stand in a line. So always it's a question on number of ways, counting. That is why we say these are counting questions, and first of all we should learn what is the fundamental principle of counting. It's a very simple concept. So just let's see. Suppose we take two events, event A. Now everything that we do is called an event. You will see this word event used in probability also. So let's say there is something called as event A. Let's say the number of ways you can select one of the shirts from your wardrobe. That is your event A. And let's say event A can be done in m ways. The m ways of doing event A, and another event is there B, that can be done in n ways. So if there are two events A and B that can be done in m ways and n ways respectively, then we can say that A and B, if we are doing them one after the other or simultaneously together, A and B can be done in m into n ways. A and B can be done in m into n ways, and if you have to do A or B, then A or B can be done in m plus n ways. This is what is called as the fundamental principle of counting. What you must remember is that and, whenever we have the word and while calculating, it means multiplication. When two things are being done one after the other, we multiply the number of ways. And when we do or, so either we do this or that, then we use addition. Let us say for example, there are 3 cities A, B and C. There are 3 cities A, B and C, and from A to B you can go in 4 ways. There are 4 different routes of going from A to B, and there are 2 routes of going from B to C. In how many ways can a person go from A to C? So a person needs to go from A to C. So in order to go from A to C, what will he do first? First he will go from A to B, and then he will go from B to C. First he will go from A to B. So how many ways are there to go from A to B? There are 4 ways of going from A to B. And means multiplication. So we are doing them one after the other. And means multiplication. And then he will go from B to C. How many ways are there to go from B to C? There are 2 ways. The total how many ways are there? 4 into 2, 8 ways. You can see number of ways of going from A to B multiplied with the number of ways of going from B to C, because we have the word in between and. But suppose a person is stationed at B, he lives in the city B, and he has a choice, either he can go to the city A or city C. He cannot go to both the cities. So in how many ways he can go to either city A or to C? So he can go from B to A, or he can go from B to C. From B to A he can go in 4 ways, and B to C he can go in 2 ways. So 4 plus 2 is 6. This is an application of the fundamental principle of counting, and while solving questions on permutation and combination, often we require to understand when to multiply and when to add, and that is the reason why we are learning this concept first. That is the fundamental principle of counting. Overall, understand that if there are 2 events A and B, where A can be done in m ways and B can be done in n ways, then A and B can be done in m into n ways, and A or B can be done in m plus n ways. Remember that when you have and, means we are doing things one after the other, then we multiply, and when we have or, we add. Alright, this is the understanding of the fundamental principle of counting as required in permutation and combination as well as probability. Next we have to understand what is permutation. So in permutation two words are there, one is per and then we have the word mutation. Now mutation means change, and per means every. So that means we are counting the every way in which something can be changed, right, and the number of ways of doing that is the number of permutations. Clear? So permutation then deals with order, it's an arrangement question, number of ways in which something can be arranged. It always deals with arrangement, and in arrangement order is important. So remember this, whenever we have a question of permutation, order is important. So for example, if you take three letters A, B and C, in how many ways we can change these three letter sequence? One of the sequence is A, B, C. So how many ways we can change? Let's count those number of ways. So one way is already given to us, A, B, C. Another one could be A, C, B, and we can see clearly that A, B, C is not same as A, C, B. Now we can also start with B and say then the third way would be B, A, C, and the fourth one would become B, C, A. So every time we are changing the sequence, we are getting a new sequence, new letter combination, B, A, C, B, C, A, or we can say C, A, B, and you can take C, B, A. Each of these sequences distinct from each other, right? Imagine your pin code for your ATM or credit card. If there is a particular sequence, let's say 1, 2, 3, 4, then you have to type the sequence 1, 2, 3, 4 for unlocking or withdrawing money from your card. Just using the same digits 1, 2, 3, 4 in any order will not open or not unlock the card or allow you to have transactions using the card. Clear? So every time we change, we get a unique sequence, and each unique sequence is a arrangement. And how many arrangements we have here? We have total of 6 arrangements. So we can say there are 6 permutations. How many permutations are there? 6 permutations. So ideally, when dealing with questions on letters, we always talk about permutation. Let's take for example the number 12. If I write 1 and then I write 2, the meaning of it is 12, whereas if I change the order and write 2 first and then 1, then it becomes 21. Clear? Again, while working with numbers, the arrangement of the digits is very, very important. Clear? Also, when we talk about arrangement in general, let's say for example there are 10 persons seated in a row. Now who is sitting to the left end of the row and right end, and what is the order of all the people in the row? That means every time we change the position of one person, we get a new order, and order is important there. Clear? So questions on letters and words, so you can understand these keywords, you must know these keywords. Questions on letters and words will always be question on permutation, because in letters and words order will be important, and then we have questions on digits and numbers, which will always be questions on permutation. So digits and how many 4-digit numbers can be made using the digits 1, 2, 3, 4 and 5. So again, every time we have a particular order of the digits, the number changes. Clear? The questions on digits and numbers are questions on permutation, and then we have questions based on arrangement, seating arrangement. So any question with arrangement will be a question on permutation, whether it's a linear arrangement or arrangement around a circle. Overall, if you are in doubt about whether to do permutation or combination, you always ask yourself, is order important, right? When I change the order of something, does it give me a new meaning, a new value? Clear? If it is giving you a new meaning, a new value, if it is different from the previous cases, then it's the question on permutation. So permutation deals with arrangement, and in arrangement order is important. Clear? Every new way in which something can be arranged becomes a permutation. The total number of permutations are the total number of ways something can be arranged, and that is what is permutation. Clear? So, we have understood the basic concept of permutation. Later on we will see the formulas that are there which help you solve questions on permutation. Before that we will see the previous session contest question. How many meaningful English words can be made using the letters PART? So, the letters given to us are PART. Now, they can be arranged in a number of ways. You see the total number of ways they can be arranged, that is a question of permutation. That will be answered with 4 factorial or 24. But every way in which they can be arranged does not give me a meaning. It should be, I am asking you about meaningful English words. So, if I put PTRA, now what is the meaning of this PTRA? There is no meaning to this word. So, we are looking for only those arrangements which give you meaningful English words. So, how many ways? Now, one you can see very evident in the sequence given in the question itself. One word is part. Like how many parts are there? Okay. So, PART, part, that is one word. Now, what else can you do with P? If I take P, I can also say it is Prat. Now, this word you might not know. Prat means a person who is stupid. A stupid person can be called a Prat. What else we can do? Now, one very easy word is trap. Now, he set a trap for someone. Okay. So, trap, TRAP, and another word which is not used so much in India, but is common in the US is the word tarp, which is short for tarpaulin, right. It is kind of a plastic sheet that you put on top of buildings, that is a tarp. And then another word which is a genuine word, that is rapt. Rapt means you are spellbound or fascinated with something. So, for example, you can say the audience was listening with rapt attention to the speaker's speech, right. So, that is RAPT. So, what we see here is that total we get 6 words. It is a question of vocabulary so much, 5 words in fact, 5 words are there. So, 5 words we can form by the letters PART, and these are all meaningful English words. Okay. But you see, every time we arrange them, this also is an arrangement question, and if I had to find out the total number of ways in which this can be arranged, the answer will be 4 factorial, and you will see how we get this 4 factorial later on in the discussion today. Okay. The total number of ways in which we can arrange the letters PART is 24. Alright. Now, let us see the contest question for this session. In how many ways you can send invitation to 5 friends through 3 servants? Let us say you have 3 servants who work for you, and you have to invite 5 of your friends for a dinner party, and you want to send them invitation letters. You have 3 servants. Now, how many ways you can invite 5 friends for the event? Through the 3 servants, by sending invitation through the 3 servants. Clear? Now, think about it. What kind of question is it? Is it a question of permutation? How will you solve it? And then you can post the answer in the comment section. I will be discussing the solution for this question in my next video session. Now, let us continue with the topic of permutation, and we will start with the important part of the class today, that is permutation formulas. The first one, that is n distinct things can be arranged in a row in n factorial ways. This is the most important formula for permutation. First of all, focus here on the word distinct. We are talking about things being distinct, different from each other, unique. If the things are not distinct, then we cannot have permutation. For example, let us say if I ask you how many ways you can arrange the letters A, and A. Now, all the 3 A's are same. Now, you can keep changing the order for your entire life, but you will keep getting the same A, and A every time. So, there is no way we can arrange them in only one way, but if things are distinct, then we have number of arrangements. For example, if we have A, B, C, we can have a number of arrangements like A, C, B, or we can say B, C, A, or B, A, C. So, you see, when we have things which are distinct, we start getting more number of arrangements. C, A, B and C, B, A, we have 6 arrangements. And what is 6? 6 is nothing but 3 factorial. There are 3 letters here, 1, 2, 3. So, 3 letters can be arranged in 3 factorial ways, and that is what this formula is telling you, that n distinct things can be arranged in a row in n factorial ways. Let us take an example question to understand this formula. Let us say you have 5 digits, 1, 2, 3, 4 and 5, and you want to make 5 digit numbers. Okay, we want to make 5 digit numbers using all of these 5 digits. That means no digit can be repeated. So, in how many ways we can do it without using the formula? Let's find out in how many ways we can arrange, or how many 5 digit numbers can be formed using the digits 1, 2, 3, 4 and 5. Let us start from the leftmost position. Until now we have not used any digit. So, the leftmost position can be filled in 5 ways. I can put 1 or 2 or 3 or 4 or 5. That means the number of ways in which the leftmost position can be filled is 5. It can be filled in 5 ways. Let us say we have used one of the 5 digits here. Let us say I have used 2, then I am left with only 4 digits now for the next position. That means I cannot repeat 2, I have to use all the 5 digits. So, the next position can be filled in 4 ways. Clear? Now, I have used 2 digits. So, now we are left with only 3. Next place can be filled in 3 ways and the next place in 2 ways, and finally, the last digit that is left will go in the last position, that is 1 way. Now, we fill the leftmost digit and then the next digit and then the next and then the next. That means we are doing and, not or. That means we are going to multiply 5 into 4 into 3 into 2 into 1, and that is nothing but 5 factorial. So, you can clearly see here that n distinct things can be arranged in n factorial ways. 5 digits can be arranged in 5 factorial ways. Alright, now we will go to the next formula of permutation. Now, this formula deals with those situations where some number of things are identical. If all the things are identical, as we have seen earlier in the example of A and A, then we have only one way of arranging them. But what if all things are not identical? Let us say 2 are identical, A, 2 A's and 1 B. In how many ways we can change this? We can say A B, or we can say A B A, or we can say B A. So, we are getting 3 arrangements, 3 ways, not 1, we are getting 3. If all the 3 were distinct, we would have got 6 ways, 6, that is 3 factorial, but there are 2 A's that are repeating. So, divided by 2 factorial, 6 by 2 is equal to 3. So, what we should do when things are identical, we should divide the total factorial by those number of factorials which are same, number of digits which are same, or things which are same, not just digits or letters, but things which are same. So, if out of n things, p things are identical, q things are identical and r things are identical, and the remaining distinct, the number of arrangements are given by this formula n factorial by p factorial into q factorial into r factorial. Let us take an example question. So, in how many ways you can arrange, in how many ways you can arrange the letters of the word successful? In how many ways you can arrange the letters of the word successful? Okay. So, let us look at this word successful and see how many letters are there, and also observe how many letters are repeating. So, if you count the number of letters, you see the number of letters equals 10. There are 10 letters in this particular word. Number of letters equals 10, but are all the letters distinct? No, some of them are repeating. So, you can see very clearly that S is repeating 3 times. So, S is repeating 3 times, and then you can see C is repeating 2 times, and also you can see that U is repeating 2 times. U is here and here. So, U is repeating 2 times. So, we have number of letters equals 10, S repeats 3 times, C repeats 2 times and U repeats 2 times. So, what will be the answer? Using the formula given above, we can say n factorial, that is 10 factorial divided by 3 factorial into 2 factorial into 2 factorial. So, you can leave the answer in factorial form based on the answer option given to you in the question, or we can also simplify it like this. We can say 10 factorial divided by 3 factorial into 2 factorial whole square. That is the number of arrangements of the letters of the word successful, and this was one of the most typical questions that would get in bank exams. If you see the papers of 8, 9, 10, 2000, that is 2008, 9, 10, 11, 12, almost you see every paper contained one question based on this particular formula. So, if you are going to get a question from permutation, most likely it is going to be based on this formula. And this formula, there is one more advanced question that you should know, and that is when we have a condition or constraint given to you. So, the same word I take, I am not writing the full question, I am just taking the same word successful. In how many ways you can arrange the letters of the word successful, and I am adding a condition here such that the vowels come together. Now, the technique that you will see in this question you can use in all such questions where some number of things have to be together. Let us say there are 8 persons and they have to be made to sit in a row where 3 of them want to be together. So, in all those questions in which some things or some people want to be together, we can use this technique. So, in how many ways you can arrange the letters of the word successful such that the vowels come together. So, you see here how many vowels are there, U, E and U. So count 3, even if something is repeating, count it. Okay. So, there are 3 vowels, that means there are 7 consonants and there are 3 vowels. We want the vowels to be together in a group. So, we will say okay, the 3 vowels, let us call them as one group of vowels, and then we start looking at them as one instead of looking at them as 3, one group of vowels. So, that means now how many things are there? 7 consonants, 7 consonants plus one group of vowels equals 8 things. What is repeating, what is not repeating, do not worry about all those things right now. Just see how many things are there. 7 consonants plus one group of vowels equals 8 things, and 8 things can be arranged in 8 factorial ways. So, how many ways we can arrange them? 8 factorial. However, this one group of vowels contains 3 vowels. Suppose there are 3 persons on a bench. Now, they can be on the same bench, but their positions can be changed. So, the 3 vowels can be arranged among themselves in 3 factorial ways. Okay. Now, this is our numerator. Now, denominator will depend only on the things which are repeating. So, S is repeating 3 times, C is repeating 2 times and U is repeating 2 times. So, divide by 3 factorial into 2 factorial into 2 factorial, cancel out 3 factorial, and you will get your final answer 8 factorial divided by 2 factorial whole square. So, these are the number of ways in which the letters of the word successful can be arranged such that the vowels come together, and this technique can be used for all such questions where things are together, some things are together. Alright. Now, let us move to the next question, that is circular permutation. When n distinct things are arranged in a straight line in a row, then its answer is n factorial ways are there. But if the same n things are arranged around a circle, then the answer is n minus 1 factorial. Now, the reason behind this is that for every n arrangements in a line in a row, there is one arrangement around a circle. We divide the total arrangements n factorial by n and we get n minus 1 factorial. Okay. So, just for the time being, just keep this much in mind. Say if there are 6 persons and they are seated around 6 persons seated around a circular table. So, in how many ways you can do that? The simple answer would be 5 factorials. 6 persons seated around a circular table. So, we are arranging them around a circle. The number of ways would be 6 minus 1 factorial, that is nothing but 5 factorial. Understand, half of this will be clockwise arrangements. So, if someone is asking how many clockwise arrangements are there, then the answer would be 5 factorial by 2, and how many anti-clockwise arrangements are there, the answer would be 5 factorial by 2. So, total number of arrangements, let us say total is equal to n minus 1 factorial, and then you can say that clockwise arrangements equals n minus 1 factorial by 2, and anti-clockwise also equals n minus 1 factorial by 2. Okay. Now, there is a special case in circular arrangement that needs to be understood separately, and the special case is when in those questions in which clockwise arrangement is same as anti-clockwise arrangement, not the number. Okay, the clockwise arrangement is same. The clockwise arrangement is same as anti-clockwise arrangement. When does this happen? This happens when we talk about examples could be a garland or a necklace. Now, these can be seen from both sides. So, suppose if I am holding a garland like this, what is clockwise for me would be anti-clockwise for you. Okay. So, that is what we mean by we can flip it over, the garland can be flipped over. So, anti-clockwise and clockwise become same in the case of a garland or necklace. So, in this special case, the total arrangement itself becomes equal to n minus 1 factorial by 2, and we do not talk here in terms of clockwise and anti-clockwise because both are same. The total arrangement in the case 6 things are arranged around a circle, let us say 6 different colored flowers are arranged in a garland. In how many ways we can do it? That would be 6 minus 1 factorial by 2, that is 5 factorial by 2, and that is 120 by 2, which is 60. Alright. So, just understand the special case when we take total arrangements as n minus 1 factorial by 2. Overall, you can see in normal situations total is n minus 1 factorial, but in the special case total is n minus 1 factorial by 2. In the normal case total is n minus 1 factorial, clockwise is half of that and anti-clockwise is half of that. Clear? Now, next move to the next formula, and that is the typical formula that we normally associate with permutation, NPR. When you say what is permutation, people say NPR. So, NPR is one of the formulas of permutation. Okay. So, n distinct things can be arranged taken R at a time. So, there are 10 persons, but only 4 chairs. So, we cannot make all the 10 persons sit on the 4 chairs. So, we can find out in how many ways 10 persons can be seated around or seated in a row of 4 chairs. So, we are taking n things, this is your n and this is your r. Always keep in mind that n will be greater than equal to r. N distinct things can be arranged taken r at a time in NPR ways. What is this NPR? NPR is equal to n factorial upon n minus r factorial. Okay. So, for example, the question here 10p4 would be 10 factorial divided by 10 minus 4 factorial, that is 10 factorial by 6 factorial, 10 into 9 into 8 into 7 into 6 factorial divided by 6 factorial. We can cancel 6 factorial. 504 into 10, 5040 ways. So, how many ways we can do it? 5040 ways. That is how we use the formula of 10 NPR. However, every time you get a question like this where we have n things and we have to arrange them r at a time, you cannot directly take the formula. So let's just understand the situation here. Suppose you are given digits 0, 1, 2, 3, 4 and 5. Now using the digits 0, 1, 2, 3, 4 and 5, how many 4-digit numbers can be made? How many 4-digit numbers can be made using the digits given above, such that, now we will add two conditions here, such that A, no digit is repeated. So that means a digit can be used only once, no digit is repeated. That is one scenario, and the second scenario is when repetition is allowed. That means there is no condition added, so repetition is allowed. So we can repeat a digit. So the answer will change for both. So first let us look at A. No digit is repeated. There are 6 digits here, 0, 1, 2, 3, 4, 5. We have to make 4-digit numbers. So can we say the answer is 6p4? No, we cannot say the answer is 6p4. There are 6 digits given to us, so there are n things. We have to arrange them r at a time, 4 at a time. Total arrangements are 6p4, but that is not the answer here because we are looking for 4-digit numbers. When we take the formula NPR, it calculates equal possibility for a particular thing to be in a particular place. That means when we take NPR, that means we are also counting those numbers in which 0 is in the leftmost place. And when 0 is in the leftmost place, it is not a 4-digit number, it is a 3-digit number. So how do we solve this then? We can solve by using the formula also, but a better way of solving it is like this. We should start counting one by one the different number of ways in which each of these places can be filled, starting from the leftmost place. 0 cannot come here, any of the other 5 digits can come, so there are 5 ways. In the second place, now we have used one digit which we cannot repeat in the second place, but in the second place onwards 0 is allowed. So we still have 5 choices, so 5 ways, we can fill the second place in 5 ways, then the third one in 4 ways, the last one in 3 ways, and when you multiply them, 25 into 12, we get 300 number of ways in which we can make 4-digit numbers using 0, 1, 2, 3, 4, 5, so that a digit is used only once is 300. If you had used 6p4, you would have got the answer as 360, that would be wrong. That would be the answer if I am using 1, 2, 3, 4, 5, 6. If I am using these 6 digits to make 4-digit numbers without repetition, then the answer is 360, but here 0 is there. 0 is there, you have to be careful while solving the question. Now the next one is the second question, when repetition is allowed. When repetition is allowed, we obviously cannot use the formula NPR. What we use is this dash diagram. We start finding out one by one how many ways we can fill each of the place starting from the leftmost place. The leftmost place can be filled in 5 ways. Although repetition is allowed, that does not change anything. 0 still cannot be placed in the leftmost place because the number needs to be a 4-digit number. Leftmost place can be filled in 5 ways, but the next place here, this can be filled in 6 ways. We can repeat the digit used in the leftmost place and 0 is allowed. Same with the next place also 6 ways, and the third one also 6 ways. So total number of ways will become 5 into 6 into 6 into 6, that is 1080. So we have gone through the different formulas of permutation, basic understanding of what is permutation, and all the formulas with brief examples of using those formulas. Clear? So go to the video again, understand these 4 formulas of permutation, and you should be able to solve any question from permutation that comes in your examination. So now is the time for the class practice pack, in which I have 10 questions. I have selected 10 questions from permutation for you, through which you can revise the techniques discussed in this particular session. Those who have passport access can start solving the questions once you hear the sound, and the question that most of you will get wrong, I will be discussing in my next session. So best of luck to you and thank you.